start now. My name is Karen Turrell. I'm the operations manager at Peace, and I'm looking after the technical support of today's webinar. And firstly, welcome. We'll start our webinar in a few moments, and you can chat in the chat pod in the bottom right corner if you have any audio issues. And so we'll start with a brief welcome and give you some background on Peace and RPS. Then Robin will give her presentation. We'll then have a Q&A session and a few closing remarks. So I would like to just tell you a little bit about RPS. It's a global consultancy offering a wide range of consulting, advisory, and operational support services to the oil and gas industry. Peace is one of two training companies owned by RPS, the other is Nautilus World, and between us, we offer a wide portfolio of classroom courses and online webinars to the upstream, midstream, and downstream sectors of the oil and gas industry. And I want to thank you for all joining today. And if you have any questions, please put them in the chat pod, which is in the bottom right-hand corner of the window. We've got half an hour allotted for this webinar, but if it runs over time, and we know many of you have busy days, we are recording the webinar, and you'll get a recording link later today. So our instructor today is Robin Marcuson, who is a board-certified industrial hygienist, specializing in the technical aspects of workplace health, safety, and environmental risk identification and management. She has over 27 years of domestic and international experience supporting various industries in their effort towards developing safe, healthy, environmentally sound, and quality operations. She holds a Master's of Science degree in Environmental and Occupational Health and Toxicology. So we'll start our webinar now. Robin, you want to take it from here?
Sure. And is on my screen now, right? So I can.
You can click the bottom slides, the arrow bars at the bottom left-hand corner.
Okay, so I can't make it wider. This is the view that everyone will have.
Oh, yeah. If you want to watch this full screen, there's a full screen button at the top right-hand corner of the presentation. So if you wish to see the presentation a bit bigger, you can watch it full screen.
Thanks. Okay. Thanks, Karen. Good morning, everyone, or good afternoon, wherever you are. I see we're in a variety of places. Thanks for filling out the questionnaire on whether or not you've worked with BowTie software or not. I see pretty much everyone hasn't. So feel free to keep your questions, and happy to answer any that you might have. A little bit about our specific group, the HSE and Risk Management Group. We originally came out of the company Riddle Blanchard Associates based in London, providing health, safety, and environmental consultancy to operators in different industries as well. We provide specialist HSE and risk management consultancy. Here's a little list of what some of our services are: risk assessment and management identification, strategy, policy, and management plans. We help develop management systems. We also help audit those or verify them for our clients, evaluate regulations and permitting requirements for new projects or ongoing operations, do competence and training. We have a large team of occupational health and hygienist specialists, environmental assessments and management, emergency planning and business continuity, and then project management and operations support for some of our clients. Another aspect of what we do, and it's included in some of these bullets I already mentioned, is use of the BowTie XP software for managing health and safety and environmental risks. So that's what we're talking about today. We also can sell the software. We support CGE in their selling and also training of the use of the software. How's that? There we go. So quick look at the agenda. Just really the aim is to discuss the use and the benefits of the software itself for your HSE risk management. We'll identify a couple of terms so that we're on the same page with terminology up front on risk, and then we'll talk about the value of the BowTie software. I'll run through a little example and then summarize again some of the benefits we'll identify as we go through that. I just want to start out by pointing out there's lots of risk in workplaces and all of our operations, financial, public policy, security, quality. Certainly those are all important, and we do feel at RPS that health, safety, and environmental protection pretty much touches every level of the operation, but today we're specifically just focusing on health, safety, and environmental risk management. So normally when we start any session with any of our clients using the BowTie or developing it ourselves, it's really important to get on the same page with a couple of very important terms. Defining hazard. Very often when we ask our audiences, whether the crew or different management level, we ask them to define the word hazard. Quite often they say a consequence, a fire or falling or slips and trips and falls. Because we always think of the negative, we're trying to be risk averse in the operation. But it's important that we really look at what that word hazard is. I mean, there's a hazard in everything pretty much we do. It is an unwanted thing because it can have negative consequences. But if you think about traveling in the air, that's a hazard, but we do it because we want to get where we want to be. Oil production or the use of petroleum is another hazardous activity. Traveling on trains, everything we do has some imminent hazard associated with it. Even sitting around sometimes. We have just, don't know how many, I think we have one person here from Florida and may be familiar with this situation. But certainly a man just sitting in his home wouldn't expect to fall into a sinkhole. So some of the risks, acts of God, we're not going to be able to completely manage out, but we certainly will give it our best try. So then defining risk itself. We're going to do a hazardous activity, whether that's traveling or producing for oil or processing or manufacturing. The events that might come out of those circumstances could either be negative or positive. Toxic release, toxic exposure, loss of production, those are all negatives. But we also want to make sure we're always focusing on the positives as well. Because if we simply control all of our negative and not focus on the positive, we won't be able to do anything. Peter Wilkinson is an expert in the risk management area. He's written over the decades many very good references, so if you have time and you want to look further into this, you might look up some of his work. But this statement's out of one of his documents, Safety Cases, Success or Failure. He states that it's probably only possible to achieve absolute safety if as a society we do not undertake hazardous activities. However, we know the application of the technology brings great benefits to us, so we take the risk. And I think we all can pretty much accept this. If we look back on regulatory control or requirements for different industries to manage their risks, they have grown through the decades. I mean, we really start seeing our regulations being developed somewhere in the 40s and the 50s. If you look at a timeline of that, you see a lot of them will just be a couple of prescriptive, maybe detailed and mandatory regulations that describe a specific solution. So if you think about a quarterly report you have to turn into the government for emissions or the OSHA accident information, this is prescriptive. Testing of a piece of equipment every quarter and you have to turn that in, prescriptive. You do it, you check the box. It only gives you control of that one item. Goal setting specifies a principle rather than the specifics. And I'm not going to be able to see entirely, this one's a little low, but at the bottom, the alert principle is very often written into the regulations now, or at least into best practices. A LARP stands for as low as reasonably practicable. Not possible, practicable, because it's very important to remember that this is a risk balance. We are going to do the hazardous activity. We're trying to get the benefits out. We're just trying to reduce the negatives to as low as we can. If it implies a feasibility acceptance, at some point it would become too expensive to do the work if we controlled every little thing. So we have to decide what the risk is and if it's doable. And finally, self-regulating, process by which an organization regulates itself without direct intervention from a regulator. ISO audits are an example of these. The API Q2 is another, but also your internal audits, your internal programs, any of the STAR programs that a regulator might put in place. All of these, as long as it's not driven specifically by requirements of the government, self-regulating. In general, aspects of all three make a quality management program. If you have all three of these in place in a good balance, you're really hitting where you really need to be. So this management system framework here is general for most management systems. It should look familiar to almost everyone. You'll have a policy at the top, standards that support it, a risk assessment process, planning based on what you have found as your risks and how you're going to control them, the supporting procedures to do that, and then the audit and the review, ongoing to constantly feedback for continual improvement of your whole program. Risk management, as opposed to risk assessment, should be an aspect of all of these. The idea that you are doing that feasibility review to get to a LARP or as low as practicable and manage your risks at every aspect of your process should be in place. We are adding the precautions to control, to put in control measures or barriers. This is the third term that I want to make put out there. We have the hazard, the risk, and now the barrier. This is a control measure. You might be more familiar with controls, but the barrier term is used specifically in BowTie. Here's just a quick little example of some of the hazard analysis methods, the risk assessment aspect of your management system. We have everything from a checklist, which would be familiar to you in a JSA, a job safety analysis, or a HAZOP, a hazard and operability study, which is really an engineering design, looking at pressures, making sure the piping perhaps is correct against the piece of equipment that will be leading into. Failure mode and effect, they look at what will fail and what will be the outcome of that in the design. Fault tree analysis, where you look also for faults, but you would also could be an event tree, like an event, when would a release happen, when could a fire happen, when could an exposure happen, and you build the tree and the controls in there. And the Swiss cheese, which is basically your hazards. These would be your barriers or your control places. Your hazards have the opportunity to be stopped at any of these if your control is working. But most controls have some sort of defeating factor. Something could happen to it which causes the hold. And if they line up correctly, they could actually go through all of your barriers. So the BowTie concept itself, it's an analysis method. No one really knows specifically who came up with it originally, but it originated in around 1979, probably in Australia. That's really where the first writings of it are really found, in a hazard analysis review. Basically, it requires an initial high-level hazard identification, and it's around a top event, an event that occurs, whether it's a release of a chemical, a loss of control of an operation. That's the event. And it's divided from the before and then the after. The threats that could lead to that event and the consequences that come out of that. And once identifying the threats and the consequences, we are allowed to place our controls or our barriers on the prevention side or the recovery side. So you can see there's not much science about why it was called BowTie. It looks like a bow tie. That's it. No acronyms this time. The software program developed by CGE incorporates a number of different analysis approaches. There's the fault tree analysis, the event tree analysis, you can see because you can build and where the trees come in, causal factor charting, and then control thinking, which was the Swiss cheese as well. Causal factor charting is just taking your causes and charting them along and see where they affect either your events or your faults. The second great benefit about the software is that after you've identified your BowTie structure, which incidentally really a number of companies do on Excel or any other different softwares where you can just document them visually. But once that's been developed, the software now allows you to still use your screening process, which is the most, which is in almost should be in all of your risk assessment procedures. This is an example of a risk matrix, but the screening, you can go in and define your own into the software, and then you will be allowed to estimate your risk in that software once you've identified your entire streamline of your BowTie. And then the third value of it is that you also get to link in your management system. So this is really the true excellent value of the software, is that it takes the traditional risk evaluation tools as a base. Then it allows you to add in your risk matrix screening and then finally your management system all into one place. So taking that, I'm going to run through a couple of examples using the BowTie. Anytime we assess any of our risks and controls, we always have the same approach, the same questions that we want to answer. What are we doing? What's the activity we're doing? What can go wrong? What will be affected if something goes wrong? What systems will prevent this from happening? Our controls are our barriers. Are we assured these systems are working effectively that will prevent this from happening? And then what systems will respond if this happens? So our controls on the consequence side. Are we assured these systems are working effectively also? So I'm going to run through a simple hazard example using the BowTie. I've built this out so we can see it. If I use the software, we'd be flying around a little bit. I'm happy to do that. If anybody else wants to, later I can open up the software, but it does fly a bit. So if you're not familiar with it, sometimes it's best to just sit still and look at the design. So the example I've chosen is a task, gauging a hydrocarbon tank. This is the hazard. It's a hazardous activity. There doesn't have to be a negative outcome, but there could be. The event would be the uncontrolled release of hydrocarbon. And we can go in and build our threats and then our consequences in the next step. So here's some threats, example threats. Perhaps one of the threats is we have multiple tanks. It's a tank battery, so we have a larger potential for exposure. Perhaps we're doing flowback operations, so the chemistry and makeup of our produced water is higher in chemical risk. Perhaps we have vapor recovery units present and they have to work on, and there's a potential for concentrated exposure. These are examples of threats you would want to build into this task. On the consequence side, perhaps we have personnel exposed to hydrocarbon vapors, personnel exposed to reduced oxygen level, perhaps a fire. These are consequences that could come out of this task. I might mention, this is very often done in a team with either specialists or sometimes the crew doing the operation, best if it's a combination of both. Certainly doing this on a silo by just one person alone is not the best approach unless it's going to be reviewed and adjusted afterward by a team. So we have our hazard and our event. I'm going to take just one of the threats and break it down to the next steps into using the software and adding in your barriers or controls, if you like that word better. I'm going to choose the multiple tanks, the tank battery. These are example barriers that may be there. Perhaps we have remote tank gauging. Perhaps we will have the tank gauging procedures. And perhaps we have a thief hatch pressure indicator. There may be other items in here as well that might be placed in there that you have barrier controls. Certainly you would put them along here. The idea is to put your most effective control closest to the threat if you can. Sometimes they're about equal. And break it down so you can visually see as I go along, do I really have a strong barrier? If this one's out, do I still have a strong one, etc. That's the great value of this as well, as you can really visually see what you have in place. Then on the consequence side, personnel exposed to the hydrocarbon vapors is what I've chosen. Barriers could be emergency response procedures or equipment, and then the respiratory protection. And when we go back and build out our barriers, this is where we get the value of really being able to put our management system all into this same documentation program and visual program. We have the tank gauging procedures and the thief hatch pressure that I've used just for space considerations. Once I define my barrier, I can go in and fill out responsible party, the barrier type, whether it's an engineering design piece of equipment, or is it a procedure, or is it hardware. The criticality, which is very important, especially if you have events that are what we call a major event, a fatality or multiple fatalities are associated with it, or large environmental damage consideration or asset or even reputation. And the piece of equipment, whether it's critical, that closest to the threat, or whether it's further away. It's not a critical piece of equipment, but it does help. The effectiveness is also very important to visually be able to see, wow, are we really controlling this the way we could? Or are we missing, we have a great big hole in our barriers. And then finally, we can put some more information about the type again, further define that there's a number of barrier codes we could use. For operation support and their use, this is particularly useful in one, identifying who's responsible. It's crucial that every barrier have only the responsible position assigned to it. If you don't know what that responsible party is, then you have a very good, Karen, there's a hand raised. Do we want to wait for that's a question? I guess
we'll take questions at the end. But if
okay,
you want to
I'll just hold that for Paresh. I'll just hold that for Paresh. Thanks. Sorry, I just looked up and saw that. He'll be when. Okay, so you must have the person identified. Very important for control and making sure that it happens, and really important for training and communication to the person what their responsibilities are. Then we are able to identify here the supporting documents or procedures. For instance, tank gauging procedure, there may be a field tank gauging procedure. There also might be the JSA procedure. Those two procedures would be applicable here. Maintenance on the thief hatch would be another one when we can identify the maintenance code. And what's great at this point, you can even link in your documents. So if you wanted to go so far as once you've identified all this and the person, if I was an operator and I was going to do this procedure or audit it or look at a task that might be a little different, all I have to do is pull up this procedure, see that I have all these procedures that I should be pulling out to make sure I have it done, and I can even pull them out if I've got these linked in, which is a great aspect of the software. And then finally, there's a second level, the defeating factor level. And I admit you could do this until the cows come home, but it is really crucially important, especially for, again, those major events or critical events, to really take a look at your barrier and say, okay, is there anything that would take this barrier out and make it not usable? That is called a defeating factor. So for instance, we have the procedures here. One of the defeating factors might be operator error, and one of our barriers we would then add to there would be training. And again, we can add documents as all we like in there. And then finally, taking our matrix, once we have identified our whole chain of events, on the consequence side, we take the rankings and we use our screening matrix and we can place it in here. This is the residual risk considered once we have added all our barriers in place, looked at whether they are effective, not effective, critical, not critical, etc. And if we find we have holes or we have an unacceptable level here, certainly anything red would be unacceptable, then we can go back and say, okay, we have now determined we need to take a look at this and perhaps put another piece of equipment in, change our procedure, something like that. This is just the tree view on the software. You can see all of these elements when we're identifying the steps that I just did, whether it's the actual bow tie itself, whether it's a barrier, all the codes here. There's activity categories, the codes, the consequence, the escalation factors, and then down and below where the linking where we would put in the activities. On the document links, all of those we can link in as well. So the tree allows us to do a number of defining into that whole diagram. On the report side, this is really valuable for the operations side because there's many different reports you can put out depending on what you're trying to find out. You can separate it by activities or actions, a barrier type, the hazard itself, even go into guidelines, for instance. If you are looking for engineering and you're looking for all of them that you've identified what design specs you want, you pull them up by that. And certainly the job titles is very useful. So the example I gave you was a task. I just want to point out that really the software is what you need to make of it. We have a number of our clients that we use it every day in their hazard analysis for the tasks that they're going to do that day, all the way to the engineering design. This is a process example. So this is hydrocarbons in the formation, loss of containment from the well. So this is drilling. So instead of just being one task, this would include the entire process of drilling. There are 3 threats here, you can see that, but once you open up these, you would see that there are a huge amount of barriers and defeating factors identified in the well. Of course, there's a number of outcomes that occur if you lost control of the well. And then even further out, we can link different processes together into one entire operation. So you can see this circles on the left identify another bow tie chain. So we've built maybe one process, and within another, this example is, well, I can't really see it, but perhaps if it was helicopter operations, you could also say, add on there that you have medical emergency as one of your bow tie, and perhaps it links into one of your threats. So you can take all of your bow ties and tie them together to see the entire operation, because you know that things escalate or they affect. Once an event happens, they could affect another process as well. So it allows us to link those together and see them. I mentioned a little bit the usefulness of 2 operations once you have this document, how they can use it. This is this line here on the right is SAMS, which is the Safety and Environmental Management System, which originally came out of the API Safety and Environmental Management Plan document, which is now required in the Gulf of Mexico for offshore operations. But if you look closely, you'll see it's structured like most management systems. There's a hazard analysis, there's operating procedures, etc. So once you've looked at your events and your barriers, you can now build back into your programs. You'll be able to strengthen up your training, your mechanical integrity if you find that you really don't have the mechanics that you should, etc. So it really helps you go back and improve your management system, find areas where you might be missing something, make sure you have the right training in. Oh, I should have mentioned there is a new add-on to the XP software called BowTie Server, because not everybody wants to work inside of the software. And certainly all of the reports I mentioned earlier you can get in Word or Excel, or the entire BowTie can be PDF'd. But sometimes if you're linking all your documents in there, you would like everyone to be able to get into it, but you don't want them to have to use the software itself. So BowTie Server allows just the use of the information that's in there without having to be savvy or change anything inside the XP software. So that's pretty good for mature operations that have everything in place there, for everybody in the field, or who maybe at least manager level, to be able to go in there. The other use that you have from once you've documented all the software is to be able to look at incidents, particularly if you have the consequence and you can go backwards and see what happened and get a lesson learned from it. What barrier failed? Why did it fail? What were you missing? And then you can go and strengthen it. You can do that with the software just like you can do the reports and the PDF for the documents as it is. There is also, for more mature companies who are using the software and documented everything as well, there is an Incident XP add-on to the XP software that will allow you to document while you're doing the incident, and this will be consistently the way you do an incident investigation and document them through the software. And finally, you can use all the information as well, since she's really gathered every great piece of information in the software. You can pull out reports and use those for your audit and inspection protocols. And there is also another add-on, so if you would like to use that just for your documentation. Again, if you have all the information already in place in mature operation, this can be added onto the XP. One other item that you can produce out of the BowTie XP software, which is really an excellent tool, is the Summary of Operational Boundaries, or the SUB, which is basically a SIMOPS. Essentially, it can tell you what operations must be stopped when another operation is going. For instance, an example might be a live plant and you're doing a heavy crane lift. You might want to either put in a precaution for that, or depending on what you're doing, if you're in construction, stop that activity underneath, etc. Or if it's good to go, you get a green, you can do one activity while the other one is happening. These are great to put out in wall charts in the room where everyone meets in the morning and does their planning, because they can quickly identify, hey, we want to do this today, let's look, oh yeah, don't forget we have to do this. We have to stop this operation, etc. The other SUB that comes out of it, instead of taking operation to operation or activity to activity, it takes a system. So if you have a system, perhaps your water monitor system or fire system, and it's out, it will tell you what activities can't go on in that area or at all. So that's another chart that you can be developed out this way. So finally, just in summary, we talked about the risks and the terms, and looking for barriers and making sure we have them. We did a little review of different types of hazard analysis and where we put that in, that the management control is pretty much throughout the whole system. If you want strong operational integrity, that the BowTie would take all of those into a complete tool and allow us to be consistent, especially in our risk assessment. And then finally, the outputs that we get out of it are very useful at a number of levels for the managers trying to develop or improve their management system, even down to the operators. And let's see. That's it for me for this part. I did want to thank you on the part of CGE as well. We work with them selling their software, so certainly a strong partner. And I see a number of questions there, so I'm going to let Karen start coordinating because
Yeah, certainly. And I just wanted to, for those who have to leave right away, because I know we're a little bit over time, our webinar was recorded, so we'll be sending you out a recording link. You'll also be getting a short evaluation later today, and we encourage you to complete that evaluation as it's important as we plan other webinars. So yeah, we have a few questions in the chat pod. I'm just going to open it up, I think, and see if I can read them all. Here. So we've got Russell who's asked, some regulatory agencies define risk as a consequence multiplied by the likelihood of occurrence. How do I go about defining the likelihood of occurrence?
Okay, let me go back to where we can see this. It's really going to go, BowTie XP won't define this for you because there are some things that it's assuming that you have your risk assessment procedure developed or identified the one you want to use. So if you remember, I mentioned here on the estimation screening, this is an example of a matrix that's used. This is the one that's recommended by the IADC, which is the International Association of Drilling Contractors. It's just an example I put out, but it's certainly one that in structure is familiar to most companies. And this, I think, John Laszlo, for the checklist for significant risks, this answers some of that. There's the likelihood versus consequence. BowTie XP allows you to use the screening matrix that you want, that is familiar to your company, because every company, they may have a regulator pushing them to use a certain matrix or an industry standard like the IADC. So it allows you to use the screening tool and implement that information and document it into the BowTie. So it doesn't drive you to use a certain type. So this screening risk here, Russell, takes the consequence and the likelihood. And I'm not sure if you guys can see this, but the A through E basically goes from unheard of in the industry to multiple occurrences per year at the location. That's for incidents, there's some value down there for asset, and there's some per month, never happens, wouldn't happen in 1,000 years type thing for environmental damage. But you can certainly change these based on what might be required by your organization and define them a little further. This is the matrix you would use for that. Let's see. Okay, thanks. And then John, I appreciate you saying that, so I'll make sure. John, what type of checklist? Okay, so checklist, John. Again, it's a lot like this. Are you familiar with the ISO 37777? It's a checklist for the industry. Okay, it's a checklist for oil and gas industry. What checklists like this would be used for the initial hazard. If you remember, it's 1777, sorry. This one designs, this is when you're stepping through here, the first process really is to do this high level hazard. And most often, very often, a checklist is the driver for the hazard. The trick is getting the right checklist, certainly for your operations. But like ISO, and we could certainly, I can send you a copy of that on email if you like. But like ISO 17776, it's like a checklist that drives you through your stepping of the hazard, and that's where you identify your incidents. or your threats and then your consequences. So that checklist has been developed by industry experts. It's really the best for oil and gas anyway. And then other industries, we have some. We can help you try and find them. Chances are you might have them, but it has to be a checklist driven within there. BowTie doesn't build in the checklist because it's used for many different operations. Okay.
And I wanted to check with Paresh if you've had a chance to ask your question too, as other questions
Yes,
are coming in.
correct. Um,
So we've got one coming in about I'm a well processor. I'm in well process workover. How do I apply a BowTie XB?
in well process and workover, again, it's just breaking down your operation to tasks. The example that we've done here, essentially the activities that you were doing. Let me get to something. So your hazard would be working over a well, or you have hydrocarbon. You're still working over a well that is active, and your event still could be unreleased hydrocarbon. But your threats are going to be the activities that you do. Bye, Russell. Thanks. So you would build those threats in here as well around that event. It's essentially going to be the same. And then the consequences would be great in number. But you're still breaking down the task of the operation itself like anything else. That's for Ermelin. I hope I said that correctly.
Now just give it a couple minutes to see if we have any more questions come in.
Paresh, did you want to write yours in the chat box? Or maybe he was raising his hand, or she couldn't hear.
Perhaps. And a recording will be sent out, so if you do need to leave and you want to catch these last few questions, you'll get a recording link later today.
Mm-hmm.
Just want to thank
John's typing.
for this presentation.
Yes. I can. John just asked if I can show the interface screen of the software. I don't mind doing that, but people don't need to stay for that unless they want to see it. I can open it up.
You know, I just left Robin's contact information and her phone number is now on the screen. Mm-hmm. So if you do need to email or speak with Robin later, she'll be happy to answer any questions.
Okay.
So for those who want to take down her information, and meanwhile, Robin will fire up the software.
Yeah. And tell me, that's not what I wanted to fire up. Are you seeing my screen?
Not yet.
Okay. Let me open it up.
You might need to open it in another pod, Robin.
Yeah, I'm just getting it through my.
Okay.
I'm finding it. And I will open it. Okay. So let me get back to here. Pod.
Yeah, new pod?
Yep.
New screen share pod? Okay.
Add new share, correct?
Yes, and I'm
share
going
my
to
screen.
drag it over to the main screen here.
And
actually see it.
Can you see it?
Yes, and now let's see if I can make this
okay.
bigger. There we go.
Okay. But now I can't see necessarily comments. Okay,
John,
you see it. Okay, I'll just look for that little red box. Oops. All right, I've got it. So here's an example. This one's built out, so it might get a little dizzying. So this is the software itself. I've closed the tree I mentioned earlier. So if I wanted to open them up, you can see all the definers that we looked at before. Support document of the webinar. What does that mean?
Maybe she's looking for the PowerPoint. We'll send you a copy of the presentation, a link, and you'll be able to hear everything. I think that's probably the best thing. The audio on the presentation should be better once you're not hearing it over the web.
Okay. Later today, right?
Yeah, we'll be sending those out later today.
Just in case she can. Okay. So then building out here, we have the SUB categories. Remember the SUB we looked at. Matrices, activities. This is where we have codes and standards that we put in there, management system documents. So you can see I should probably make this bigger. So this is built out, as I mentioned, so you can see the value. We've got a number of, these are the internal management system documents. These are codes that are in their design standards. This blanked out client. I'll close those circuits. And then here's the bow ties themselves. So this is for a drilling operation. You can see we have 20 different bow tie events that we put in there. Everything from, this is basically a blowout, hydrocarbons in the formation and loss of containment, hydrocarbons in the well test. So for the workover, it's the same type of thing. We would step through these events, especially the top, at least 9. You're welcome, thanks. Would be in there. And so then we could let's open one up. So this is, I'm going to really take it down because you can see how large they can get once we built out. There's a number of threats. This is one threat only. These are defeating factors. So if I grow back into that, it's very big. This little box is getting in my, I gotta put that box down because it's in my way. So. And I'll shut that. So when we grow, here we have the event. The hazard is the hydrocarbons. The event is loss of containment. Again, this is a blowout. This facility is offshore. Loss of containment from the formation is our first threat. Drilling into a shallow gas zone and hydrocarbon gas present in drilling fluid returns. Seems quite simple at the time, but once you really start opening them up, see there's a number of barriers that are in place. Mud column is the primary criticality, remember. Blowout preventer is secondary. Well casing and mechanical barriers tertiary. Kill well response, choke and kill system, and kick detection. We can open up one of these and see there's a number of defeating factors. Very important, especially for major events, is to really go in there and define there. We have human error for the driller, unexpected high pressure zone, insufficient mud weight, drilling mud supply system failure, well pressure changes due to swabbing and surging, existing well bore, etc. It goes on through the operation. And within there, we have a number of barriers. So you can see you can get really detailed into your operations. But I do want to point out that you don't have to use this software always that detailed. You could certainly use it in a daily way for project risk assessments, like a JSA, that for an unusual or non-routine task, for instance. Let's see, was there any questions?
I think the end of the questions.
Yeah, John, did you
John,
see that? Is that enough for now, or do you want to see anything else? Or we could certainly catch up offline. Okay, yeah.
well, I think we'll wrap this up. Thank you everyone for staying so long, and you'll get a copy of the presentation. I'm going to close this pod so that,
Great.
there we go, so you can see Bobby's
Appreciate
contact.
everyone's time and calling in.
Thank you everyone.
Thank you.